All right. So yes, it says OpenAI here. But that was to sort of pull you in, get the sales aspect to this. There is OpenAI involved, but hopefully a bit more a different angle to OpenAI. I'll skip that part. Who am I? I work at Mallow, as you probably would have guessed. I work as a data architect/engineer. I've been working in that capacity for more than 8 years now, 12 in total with like smart cities and big data systems with research institutes and universities as well. And pretty much all of that time with Azure technologies. Here are some free time activities because it's mandatory. So I have few goals for this session. First of all, use cases for OpenAI. It's always fun to sort of hear what it has been used for, because to me it has mostly been just Copilot bots everywhere, and I'm like, well, like what can I use it myself as a data engineer/architect or more technical guy? So hopefully we'll look at the use case, which was also a surprise to me. So hopefully it provides some new to you as well. Then I want to introduce a few new technologies to your toolbox. If you work within the domain or if you work in some kind of architectural capacity, hopefully you get an idea about some new technologies that you can utilize in your own use cases and environments. And then of course, if you're working in this very specific kind of problem domain, hopefully some tips as well. But yes, those are my goals. So what are we actually talking about here today? So the topic is migrating legacy data with CDC and OpenAI, and CDC stands for Change Data Capture. Who wasn't aware of what it means? Is this a new terminology?
Yes.
Yes. All right, but it seems to me maybe pretty common. But this is just the sort of what was possible after we solved these like specific problems, and the topic here is actually focusing on these very specific like problems that are stated here. The first being that how do we create structure where there isn't any? So we have unstructured or semi-structured information, and we want to add more to it. Or then if we do have structure, can we like remap it to a new structure? And then the question of how can we possibly do it in real time? Because doing anything in real time is pretty difficult. So we'll look at a bit of new technologies, how to make it possible. So a bit more deeper, more concrete into the use cases. So the one motivating aspect for example, the discoveries personally I made, and where this sort of started from was from the like use case that we have 2 generations of software running simultaneously, old one and a new one. And because of legacy, it's not realistic to touch the older one on the left side. We sort of want to start a greenfield solution, but we want to have the data migrated real time while both of these systems and generations are running simultaneously. So that was the sort of motivation to also start looking into this. And then the second part, or the domain that these problems I've used in my work is in reporting. So when either getting data out of any kind of operational system or whatever sources are out there, we want to add more structure to it. We want to calculate metrics numbers for that unstructured information. So we'll be sort of working in these domain areas, and if you have any questions, I'll try to sort of give my input on those. So going even more into the concrete level, what are we actually trying to do here? So we have I mentioned some like data mapping, I might mention some like adding some structure. So on the left side here, we have the sort of legacy part, or the part that we are sort of trying to add structure or restructure into a new format. So we have, for example, structured a legacy system that has organization table and there is name column and there is there's structured information, but it's with the, let's say, different name, different concepting, different data model. And we want to sort of find a place to it in the new place. And then we have this unstructured information, like whatever might be values from the old database, might be something gathered from the user feed, like application, some feedback or whatnot. But we also want to find a place for that in the new structured data model. So pretty much finding in these different scenarios a place for that new data or adding new structure to it in the new environment. So yes, finding mapping for the structured information, for the unstructured, classifying the text to some known categories, like we had here, that there's a sentence, we want to add it to category, or we want to sort of build metrics, for example, based on these categories, how many user complaints we have for these different categories or projects or whatever metrics or unstructured information you might have. You want to calculate some information for that. But then, if I structure the sentences a bit differently, it's the finding the closest concept to whatever is on the left side from the right side. So we're working with the same problem domain, even though the use cases on this level are like sentenced a bit differently, but it's the same problem actually behind it. And this is what we are focusing here on. And how do we then start doing that in general when working with unstructured, or when we want to utilize OpenAI or any kind of like this automated AI functionalities for this kind of problem domains, is that we take the information, textual information, and we transform it into embeddings, so vectors. And who here is familiar with embeddings or vectors? All right, so few, good. But we'll cover those a bit, what those are. So what embeddings are: text, like the sentence, or we might have a person table, organization table, or whatnot, and then a column called name. So we combine those to sort of have this. This is a bit simplified example. So we combine those so we have a sentence pretty much describing an entity and then add its attribute. And we want to we take that through the ML AI model, which transforms it into an array of numbers. And it's nothing more, it's just an array of numbers that then reflects the AI model's understanding of where the concept is placed in like X-dimensional grid. So, and where the OpenAI comes in is in the quality of the positioning and the conceptualization of that model in the numerical format. Oh my God, what a sentence.
Quick question.
Yes.
Is this like text clustering in that sense?
It's clustering, yes. I mean, it enables you to do clustering because you need to transform it into numerical format so you can do mathematical operations for that information. Question?
What exactly do you vectorize? The name of columns, or?
We vectorized like the name of the table and the column. So that gives us, because the table name, it's like person, it's organization, and then that table has a column called name, or first name, last name, like, because they describe entities. And it was simple for us to just combine those, and we get like this meaningful sentence like person name or organization name, or it could be organization like the address, or what is Y-tunnus? What is it called in
business ID?
Business ID, yeah. So because it was a simple thing, just take the table name and the column name and combine those, and you have this like meaningful concept in a textual format. So it enables us to then transform that into vectors that we can compare to the new table or new data model, because that as well is the data model is modeled according to like these known concepts, and then it also have a person name, or it might have employee name, but then when that's transformed into vectors, we can compare these, how similar these are. So the why the OpenAI model is used here is because of the quality of the numbers that it generates. And by the way, there is now, it was just a week ago announced this, at least this new blog post came out about this, like the new embedding models. The old one, which is this ADA002, you didn't have many options when working with that or when transforming it into vectors. And it gives you over 1,500 numbers long an array. So that's quite a bit of data for a single concept or word or sentence. But with these new models, you can put it to even like, you can put it to 256 number long array, which then reduces the data amount a lot and lets you do math a lot quicker. So this is really interesting. This is right out of the oven. So go and read about that. But yes, text are arrays, pretty much. And what then you can do once you do some simple mathematics based on these vectors, we get the information, for example, that organization name equals company name. And this is when I talked about the first use case that we want to do mapping of information from old structure to new structure, this is what it's based on. We find the closest similarity from the new data model, and then we formulate a sort of automated mapping for that information. And the closest thing, finding the similarities, is the one aspect you can do with it. But then, of course, if you're doing any kind of metrics calculations or you just want to find clusters, then as well you can take some known concept or word like business or healthcare, and then you can try to find from this coordinate system the closest concept for that word and sort of get the number. Okay, we have, let's say these are, let's imagine they are like project names or user feedback. Then I could sort of classify, find the clusters, find the number of different feedbacks for any given business or healthcare or whatever topic domain that we have. Yes?
So, but you only use the table names and those, not the actual values themselves.
Yeah, not the values in this case, because we only wanted to like do this column in this table correlates with that column, with that table and that column in that new data model. And that was the only meaningful sort of information that we needed.
Do you somehow connections between table like foreign key?
Oh no, it doesn't go that far that we sort of automatically create foreign keys or any kind this kind of information. That comes from like once we built the new data model, it has its like greenfield. It's like you build a data model from the ground up, how you would want it. It has its like you decide the foreign keys and whatever you want in that model, and then we just needed to solve okay, how do we map an old data model, regardless of what.
In the old one, there are foreign keys.
Yeah, but it doesn't like we don't care about that because it's just about we want to just move data from another table to another table, but we want to do it in an automated fashion because we don't want to manually write all the mappings because as the use case was, there was so many, it's impossible or it would take weeks and months for someone to manually write all the mappings. But yeah, so this is the sort of the basics of the problem domain and how you solve the problem that I stated. And now going a bit more to the actual use case. So we start off with the live service data migration, and because solution pictures was always nice, here's a picture. But this was pretty much the setup that how we took a legacy system, how we transformed it into a real-time database for us to listen changes on and then do these like mapping calculations real time and put it into a new data model. But as we are doing, we are having two operational systems running side by side. We want, of course, the path to be as real time as possible. So latency was critical to get as low as possible. And for that kind of use cases, and then of course you need to, or you want to pre-calculate or pre-compute these like mapping pairings So pretty much we took the old data model, new data model, calculated all the vectors, took all the nearest like calculations for each pair, and then just put it into a Redis database so that whenever a function gets an event from this change data capture component that I will cover in a moment, it has all the information to do the operations as fast as possible. And yeah, so from this slide, the interesting part is to take, the takeaway is, at least that I wanted to convey, was the Debezium. Who knows about what Debezium is? 1, 2. So new technology. This is possibly for your tool belt. It goes well in Azure as well. It's an open source tool, a software that you deploy. It works natively on Kafka, so it runs as a Kafka Connect worker. You deploy that kind of, well, it's a single binary that you run on any kind of container container instance or container app that you have, and then you can scale that number by just putting the pod or instance slider up, because it works as sort of, it communicates through Event Hub in our Azure setup, and it synchronizes all the work between the different workers by itself. So it's really easy to then handle, but of course a lot of the work goes into, because there isn't a ready like biceps or anything for running this. There are containers that you can use to sort of jumpstart it, but 95% of the work goes to tailoring this to your like environment, infrastructure, writing the biceps, making sure all the networking and this kind of stuff is ready. But otherwise, it's minimal effort to transform any kind of operational, like SQL, be it MS SQL, MySQL, or Postgres, or some Oracle systems that is supported natively, and then it also supports JDBC systems. So this tool, then you just enable, pretty much tell it to point it to a database, and it starts generating events for you, in our case, event hubs. And it's, as soon as the change happens in your database, it gets put as an event to an event streaming system, and then you can process it however you want. So yeah, so a really cool technology. Take it to your tool belt. There is now with Azure, you can, if you are running Azure SQL, there is now like native function bindings for SQL database, but those are in preview, and there is some, because this has been existed a long time. It has a lot of features to filtering events, putting it to different topics, and doing some basic transformations and all kinds of stuff in regards to this. So it's a lot more holistic system than having like simple bindings for an Azure function. But that's a way if your use case is simple. So Debezium enabled that whole sort of generating events from a legacy system, and even trying to, even without this, it would not have been possible to even try to solve this. So, but as I mentioned here, that things would need to be like pre-calculated. What if your scenario doesn't allow that? What if you cannot pre-calculate the information that you want to do or map or transform with vectors in real time? And for example, these, like, you have a live application running and you're gathering like user input from the application, or just you're doing the operations on the data itself. You cannot pre-calculate data or user feedback. You have to do it in real time. And this now becomes quite a problem to solve, because there starts to be a lot of latencies involved. The easy part is, okay, we looked at that, okay, the text or values need to be transformed into vectors. You can do it by simply calling your Azure OpenAI model. It has a REST API. It's quite performant. You can do tricks to sort of parallelize that, but it does handle like hundreds of requests per second, probably, if you do some tricks. So that's the easy part. The difficult part is then when it comes to like calculating the vectors. You have a set of vectors, and then you want to find the similarities between things, and that's a heavy mathematical operation. And if you've heard about, like, there's been a lot of talk about now about vector databases. Who has heard something about vector databases? Quite a few. So those are like purpose-built technologies, and or not. There are purpose-built technologies for that, but also like Cosmos and Postgre and what else in Azure. They do have like these vector extensions and additions to those, and there Microsoft is adding, for example, with SQL, Azure SQL, you can also do vector calculations. I actually have some performance things later that we'll look into. But you can have like a dedicated technology or database for that, doing the calculations, or then you can do it in memory. So without adding any dependencies, any like external systems to this like solution architecture, there's actually a very nice way to do it in memory, and that we will look a bit. You can already see that there's a icon there called LanceDB, and that is the key that how you actually then do this in real time, in memory, without dependencies to other external systems. So what is LanceDB? It's an open source vector database specifically made for these kind of use cases, like vector calculations for AI use cases, and it's written in Rust. Who has gotten their share of like this Rust hype? Few. If it's made in Rust, it's perfect. So what is like important to understand about this, that it's in process. So it means that whatever application you are running, whatever API or function app or whatever compute you are running, it's the actual technology is like it's in that same process. It's executed in the same process. It's a SDK that you integrate, for example, to your application or REST API, and it provides you all the functionality then to do these kinds of operations. And what it relies on, there are many actually these kinds of technologies. This whole in-process technology domain that is popping up, it's really interesting. I have few extra technologies that you should look into, but it's a really interesting domain rising up. And these utilize, for example, if you have it, I will show you a demo of a Python API running, but where it actually then physically stores the data is, for example, your blob or S3 or whatever object storage that you have. But it can also be your whatever compute units disk you have. It can also be SSD if you want to really, really minimize the latencies. And because I'm a data engineer, I like to say that data platforms are important. This whole thing and this picture, this LanceDB in this picture and this problem domain enables how then you combine your data platform seamlessly into this kind of like operational use case. And we'll look about that also a bit. And it's 25 minutes and it's a demo time. So the demo is about this LanceDB here. So I want to just demonstrate that how does it look on the code, how does it perform, and really maybe try to drive the point that it's the performance is really what enables like these new kinds of use cases. So the setup that we have here is here I've just generated 100,000 documents. For all intents and purposes, this is like identical to an actual use case. It's regardless of whether it has real input or not. This like generating this random vectors here, it's 256. So it works with the assumption that we are using the new OpenAI model that enables us to use these shorter shorter vectors and still maintain high quality in the sort of finding the relevant concepts. So we are generating 100,000 documents which has their embeddings generated, and then we want to find the closest. We give this API an input, and then we want to find the closest like concept related to that from this dataset. And if we look at this, it's hard to understand how much data that is, but as a CSV, written as a CSV, it's almost 500 megabytes of CSV only. And then if you work with data, you can try to imagine that if you have 500 megabytes of only numbers and you try to do mathematical operations, it's, well, I don't know if it's slow or fast to you, but at least I get the sort of fear that, okay, it might be more expensive than it should be. And it's not, at least it's not sub-second millilatencies on high scale. It's or maybe it's half a second, but we'll look at that, how much it actually is. And then with this LanceDB, it's pretty simple. Here we just create a database. It goes to my file storage. It could very well be also your like blob storage, where it actually then creates the file, and we just put our data in there now as a setup. And the API that we have is also very simple, and it's very simple because someone has already done the work. I don't need to do a lot of heavy lifting to find the closest concepts, but it's done by this LanceDB. So it's this very simple invocation here that search, and we give it an input of another vector, and again, this is as similar as real situation can be, because this doesn't care what the actual input is. It just it takes 256 numbers and tries to find the closest other 256 numbers. And it doesn't matter whether it's generated from actual data or not. And then we return that as a payload to our REST API, or like REST client. And if I run this, and now a bit of a disclaimer that because I'm running on battery power, it's actually 50% slower. So the number that you're gonna see, it's actually half that when I plug my computer into power, but I didn't have my power cord with me to demonstrate that. I forgot it. So you have to trust my word. But yeah, we have the API running now, and then I take my trusty Postman, and the initial request is gonna take a bit more, but now if I start polling this, you can look from here that how many milliseconds the request is taking. And again, as I said, because I'm running on battery power, my laptop, it's 150 milliseconds. With power, it was 70 milliseconds. And with my home computer, which is a bit more expensive than my laptop, it was 40 milliseconds. So we are really, really working with a computational problem here. And it scales like, well, it's all it needs is computational power.
Quick question.
Yeah.
Is it like lifting the data into the memory of the application?
Yeah.
So basically,
Yeah, it works purely in memory.
okay.
So you can then, of course, do like if you have of course it expects that you can then, whatever data that you are loading, that it needs to fit into your memory. But then you have mechanisms also to optimize. You can partition your data, and I haven't even built an index yet on top of this. You can still build an index on top of this data to make it faster. But yeah, then if you are having that restriction, like you're trying to run this in a like Azure function that has like 2 gigs of memory or however much you can have with that, of course there's a limitation. You cannot try to ingest 3 gigabytes of data in there, but you can then partition it and figure it out that way. But yeah, so really, really simple. And then who works with data lakehouse, like lakehouse technologies? And is there like data people here? No. You wish. So maybe I will not dive that deep into that. But again, if we're working within the lakehouse domain, and this is really the benefit of the lakehouse, and what I am also super excited about Microsoft going into this Delta Lake or Parquet path now, is because it enables a whole ecosystem that hasn't been possible to do before, and this wouldn't be possible without them also investing in that and making sure that, okay, Delta is the de facto standard in our system. But it's also really simple. If I would want to, for example, read the vectors, let's say our data engineer team, our data platform team has been doing a lot of work collecting data from different places, pre-calculating vectors, putting them available somewhere, hoping that some operational application will utilize those for their user-facing applications. Then how will you? Let's maybe jump into the slide this point that they. Wait, where did it go? Yeah. So a bit forward. Let's jump to this first. Traditionally, it has been a bit of a drag to try to combine whatever the data platform guys are doing, or girls, to operational applications. There has been many stages, many different lifts and shifts for the data for it to end up in some kind of SQL database, and then it's there and it gets old really fast, and then it needs to be lifted and shifted again, and there is dependencies, there are errors, and everybody's screaming, and it doesn't really work. So with this whole Delta Lakehouse approach now, and with these new technologies, there starts to be these native ways for applications to integrate to the data sets, tables that the data platform is building and utilize in your applications. And yes, so maybe let's look a bit about you saw the request on my laptop with battery power took 150 milliseconds. And, well, it correlates pretty well. I mean, this is some Ryzen 5 or what was it? Does Python use, is it single core? Does it run on one core only, or is it can it parallelize stuff?
Depends on the library.
But maybe by default it doesn't really. Yeah. So you can imagine that I was running on pretty much on one core, getting the 150 milliseconds, trying to resolve the closest concept from my 100,000 vectors that I had. And the examples that I actually forgot to put the link there, but there are two Microsoft articles about also utilizing and building vector similarity searches. So just what I showed you as well. They have two examples built, one in Azure SQL, and the second one built with Azure Data Explorer. And what they achieved in their benchmarking is that with 8-core SQL, which cost 1,400 a month, they got half a second latency for their similarity search. And I promise you this was 60 milliseconds when it's connected to battery power. So, plug. So quite a bit faster for quite a bit less money. Yes?
Is that on ADA embeddings?
Yes.
Yeah. So basically there the vector size is 6 times.
Yes,
the
and
vector size you tried. I'm not saying
yeah,
that you wouldn't be correct, but there the vector size might be different.
And I can demonstrate if we want to. I ran the demo before. I have another database made with 225,000 vectors with the ADA 1,536 vectors, and the same search took 70 milliseconds. Yes?
They mentioned what algorithm are they using to calculate the closest, because I think there are many possible algorithms.
Yeah, this was...
But it's lovely you have the links.
Yeah, the links. I will add the link. You can check it. It was the Euclidean distance that they're using, and they mentioned that it can be optimized by doing something, but would it be like a magnitude of difference? And then with the ADX, so 2-node, it was like the smallest AMD machines that you have. It's 1,100 a month, and you get almost 1 second latency.
Personally, I wouldn't be surprised if you're finding was true.
Yeah.
You consider the SQL engine, you consider the age of Azure Data Explorer,
Yeah.
what it's for, and then there is this vector database that is purely for these
Yeah.
operations. So the
And built on Rust.
Yeah, built on Rust. Yeah, it must be better.
Yeah.
It must be better.
Yeah.
Okay, cool. Yeah.
Yeah. But yeah, I mean, because yeah, there's of course you can do these similarity searches with the Azure AI search as well. But to me, like having to make sure that it has indexed all the information and the latency, network latency of pulling somewhere, and it's like it's a real-time use case. I don't maybe want to do that.
Yeah.
So quite a performing thing, and you can run it on your Azure function if your data set is like small enough. If it can fit your function's memory, and so definitely an interesting technology to look at. So again, trying to add a bit to also the data platform side, as I mentioned already, that you can do these vector calculations like separately on the data platform. Okay, Databricks has its own vector endpoint as a preview, so you don't have to like use a LanceDB or some other service if you are doing vector calculations inside your data platform. Like finding the nearest and clusterings and so forth, there's a preview now about the Databricks about the vector endpoint, so, and that would probably be better to be used there then. So, summary. Bit of an imagination may be required that I can use this kind of like I can use OpenAI large language models for these kinds of use case. Whether it being real time or not, it does help you. It's not, of course, it's not like bulletproof. You still have to like manually validate that the information is correct, but it gives you like a jump start to rather than manually finding all the mappies for everything. It gives you suggestions, and then you can just approve. So it makes the workflow a lot faster. And then Debezium for transforming legacy systems into real-time event sources. And for this kind of use case, really interesting, really fun, enables a lot. And then this LanceDB, I really think this is sort of like a big future trend coming up. And especially important for us like Azure guys to also understand is that we need to start looking outside of the Azure domain. Because, for example, I can utilize this kind of open source project in my container application, or in my like AspNet application, or my whatever API that I'm building. I can utilize these in, well, actually you cannot with AspNet because they don't provide .NET, sorry, C# SDKs yet. It's mostly in this data domain like JavaScript and Python and some others, but it's growing. It's growing. So really start looking outside of Azure as well for these in-process technologies.